or pre-programmed cell death. And especially the nerves in our brain, as we get older, they tend to die off through this apoptosis process. And there's what we call an intrinsic pathway where the mitochondrial damage releases factors which activate this pre-programmed cell death. So keeping mitochondria healthier will decrease apoptosis. And finally, when mitochondria don't work properly, they're involved in activating what's called the inflammasome, which is an inflammatory process. So it's not just the derivation of energy, but they're involved in so many cellular processes. People can see why, if they're not working well, it's not just one or two things that are affected, but the whole cell becomes dysfunctional. And what we find is that the mitochondria are really in every cell in our body, except for our red blood cells, but they're much more enriched in energy-dependent tissues. For example, the heart, almost 20% of the heart mass is mitochondria. Skeletal muscle is 3 to 4%. Brain has quite a bit of mitochondria as well. So when they're not working, it's those tissues that are most affected: our brain, our heart, and our muscle. So that's just a brief overview of the mitochondria, but we can certainly get much more into the weeds on any aspect of that if you'd like.
So I was thinking about mitochondrial dysfunction is one of the key hallmarks of aging, correct? But I think you covered most of those. I mean, we see increased ROS